Hey everyone, and welcome to the second video about how does the internet work. If you haven't done it yet, I would suggest you to watch the first part of the video, in which we take a look at the whole internet infrastructure, trying to understand what modems, routers, and internet service providers are. In this video, we'll take a better look at a process called routing, and we'll see what's an IP address, and why it's essential in order to allow internet packets to reach their destination. So let's get started. So far, we've seen that given two computers in different parts of the world, if one sends a message to the other, thanks to the whole internet infrastructure, we can have a path from the source to the destination. But how does the message get delivered to the right recipient? Since all the computers in the world are connected thanks to the internet, how do we make sure that the message ends up in the right place? Similarly to how it works with traditional mail, every time a packet is being sent, the destination is represented with an address. This is called the IP address. This is a unique address of a connected machine to the internet. You can think of it as a unique location on the web. Every time a message is sent online, it will contain the address of the receiver. Do you remember that we defined the routers as traffic handlers of the internet? In this case, routers will check the address printed on the message and will route the packet in the right direction. Let's see an example together. We have three devices connected to the internet. Device A and B are used by two different people living in New York City, in the same neighborhood. The third one, device C, is in London. They are all in three different networks, but network A and B are connected to each other. The fact that network A and B are connected to each other is a key concept. This means that if A receives a message for a device that belongs to network B, it knows that it has to send the message to router B. This is important because routers do not know the IP addresses of all the other routers in the world. They might know the ones directly connected to them. And in the case they receive a message for an IP address that they did not know about, they will just send the message to their internet service provider's network. Now let's assume the case that device A is sending a message to device B. The message will be targeted to 2.2.2.2, which is the IP address of device B. Since the router A is directly connected to router B, once the message will get there, the router will know that the right path is to send the message to router B. This happens because the two networks are connected to each other, and A knows that 2.2.2.2 is an IP address inside B's network. Once the message gets to router B, it will be delivered to device B. But what happens in the case of device A sending a message to device C in London? In this case, once the message reaches router A, the router has no idea of where the address is, since none of the routers connected to it know about that address. For this reason, the message is sent to the internet service provider's network. As we said, this is a network of several routers that are connected to routers from other internet service providers. After some internal switching, the packet will be sent to the internet service provider of the person in London. During this process, the message might be sent to several other service providers until the right one is found. Once the message reaches the right service provider, it will hop across different routers until all got to router C, and finally to device C. As you can imagine, this process is called routing, and the idea behind it, as we've seen, involves finding the right path for a message in a network. So we have now introduced the concept of IP addresses, but there still is a piece that is missing. When we go online, we do not communicate with IP addresses. When you go on Google, you ask for google.com, but not its IP address. What you're asking for is called a domain. So that means that somewhat we need to translate a domain to its corresponding IP address. The final element that we'll add to our network today will take care of that, and it's called a domain name system. You can think of a DNS as a phone book of the internet, where there is a mapping between each IP address and its corresponding domain name. The DNS is a distributed database, and it can be queried by the devices in the network. So that means that in the case of device A, trying to reach google.com, it will first request the IP address from the DNS and get the corresponding IP address. And then, once in possess of the IP address, it will perform similar operations as the ones we've seen before. So this was a summary of the main functionalities on how the internet works. The big picture is there, but there's still a lot of details that are worth learning if you're interested into this field. As always, if you liked the video, please subscribe to the channel, and if you have any questions, just post them in the comment section below.